These two weapon systems look nearly identical. One cost Infinity Ward hundreds of millions of dollars to make. I built mine alone, and here's how I got it done. Modern Warfare 2019 set the standard for FPS gunplay, so that's my benchmark. Today, I'm breaking down 5 technical systems that make weapons feel professional. Procedural animation, inverse kinematics, geometry masking, custom reticles, and FOV rendering. Let's start with what makes guns feel so alive. When you're standing still in a shooting game, your weapon shouldn't just be static. Real operators make constant micro adjustments. This is better known as idle sway. Modern Warfare does this beautifully with hand-animated idle cycles. I'm using procedural animation so that the weapon responds to subtle movements algorithmically rather than playing canned animations. The result? Natural-looking movement that never repeats exactly the same way twice. But idle sway is only half the equation. When you're moving, the weapon needs to respond to that momentum. This is weapon bob. Every step creates subtle shifts in weapon position. Too much and it's distracting. Too little and it feels floaty. Modern Warfare nailed the balance, so I studied their implementation and built my own procedural system to match it. And here's a detail most players never consciously notice: reticle lag. When you snap your camera to a target, the reticle doesn't instantly lock to center. It trails behind slightly, then catches up. It's subtle, but it's what makes aiming feel weighty and realistic rather than robotic. This is the kind of polish that separates good gunplay from great gunplay, and it's all procedural. Now here's what happens when you don't implement inverse kinematics properly. The weapon moves to ADS position, and the hand just stays behind. It looks amateur because it is amateur. This is what happens when you animate the weapon without solving for hand placement. But with proper IK, the hand moves with the weapon as one cohesive unit. The system calculates hand position in real time to maintain proper grip throughout the animation. Left side, broken. Right side, professional. This is inverse kinematics. Now you might notice that my weapon sits lower and more to the right when we're at the hip, compared to Modern Warfare. That's intentional. Modern Warfare puts their weapon more towards the center for a more traditional feel. I positioned mine way off to the bottom right to keep the player's sight picture clearer when moving around the map. Less weapon obstruction means better target acquisition. But this unfortunately creates a bit of a technical challenge. A straight diagonal path from bottom right to center would expose the weapon geometry to the masking system at a very bad angle. So I implemented a custom L pattern movement. The weapon moves horizontally first, then up. This keeps the weapon properly masked throughout the entire transition while maintaining that clean sight picture that I wanted. Different starting position, different transition path, but the end result is equally professional, just optimized for different priorities. Modern Warfare obviously has this solved for their centered weapon position. But when you're building from scratch with different design goals, you have to engineer custom solutions. That's the beauty of being a solo dev. I can optimize for exactly how I want my game to play. Speaking of masking, we have to talk sight picture quality. When you look through an optic, you should only see the reticle and your target. Nothing else should intrude into that view. Most games handle this by carefully positioning the weapon geometry and hoping nothing clips into view. Modern Warfare does this very well on their low zoom optics. I tested extensively and could only see the barrel if I was really aggressively rotating the camera like this. For their higher zoom optics, they mask out the sight picture so nothing gets in the way. But I wanted a bulletproof solution, so I built a masking system with 3 separate render zones that is applied to all optics. The FPS arms, the weapon body, and the optic are all masked independently. This means that no matter what attachments you add, no matter how the weapon moves during that L pattern transition, no matter how fast you rotate the camera, the sight picture will always stay absolutely clean. You literally cannot make the barrel show through the optic. The system prevents it at a rendering level. Is this overkill for my weapon system? Maybe, but it guarantees a clean sight picture in every situation with every weapon configuration, even with my unconventional ADS paths. And that's the level of polish I'm going for with Slammer. Now let's talk reticles, because they seem so simple, right? Just a texture in the middle of the screen. But I wanted flexibility, so I built these as custom materials. This means I can change colors, styles, brightness, and even animate them, all without making a specific texture for each combination. Red dot, holographic, different crosshair styles, they're all driven by the same material system with different parameters. The advantage, when I add weapon customization later on, players will be able to modify their reticles on the fly. Different colors for different lighting conditions, different styles for different engagement ranges. It's a small system, but it's built to scale. And finally, we have the FOV problem. A field of view slider is one of the most requested PC settings for FPS games. Players want to see more of the world around them. But there's a technical challenge that comes with this. When you increase world FOV, the weapon view model distorts. It stretches, looks unnatural, and breaks the visual quality that you worked so hard to achieve. The solution? Split rendering. The world renders the player's chosen FOV, while the weapon view model renders at a locked FOV. The player gets the peripheral vision they want for their competitive advantage, and the weapons still look exactly how I designed them, whether they're centered like in Modern Warfare, or bottom right like my hipfire positioning. FOV 80, 100, 120, the world changes, but the weapon quality stays consistent. Unfortunately, Unreal doesn't have a good way to do this easily, so I use a material workaround that I learned from a tutorial by Jack French that will of course be linked in the description. And with that, problem solved. 5 technical systems: procedural animation for natural feel, inverse kinematics with custom transition paths for different design goals, geometry masking for clean sight pictures, custom material reticles for flexibility, and split FOV rendering for player choice. Built solo, coming close to matching AAA quality, making intentional design decisions instead of just copying. This is Slammer. I'm releasing devlogs as I build this game. Subscribe to follow the journey. Next time, we work on the weapon customization system. Thanks for watching.